Testing. Hello, hello. Welcome to another day of daily LeetCode live streams. Here doing a weekly roundup. For any of you that are new, for anyone that is watching, what is the weekly roundup exactly? The weekly roundup is where we take all the questions that we've been doing since last Sunday up until yesterday, and we look at the ones that we haven't been able to solve. Normally, I just start again from the first page of LeetCode and just start going down and look at any question that we hadn't solved, and we try to go for it again. It just gives us an opportunity to revisit old questions. Perhaps we've learned something new in the previous week that we were doing these questions. It just gives us some good refresh time. And it's different than the other weekday, or not weekday streams I do. It's different than the normal LeetCode live streams I do, in the sense that in the normal LeetCode live streams, we're always pushing forward. In weekly roundups, we are revisiting previous questions. So if you're here, if you're new, if you like this sort of thing, make sure to subscribe to me on YouTube, ring that notification bell. It really helps me out. If you're on Twitch, love the support I've been getting there too. I promise I know I need to be a little more into Twitch. I've been so focused on YouTube. I'm going to start focusing a little more on Twitch. So if you're on Twitch, make sure to follow me on Twitch. Keep me around. This is a good way for you to get involved with LeetCode, and I hope to sort of provide a different perspective on the whole journey that is LeetCode. So without further ado, let's get started. We're currently sitting at 184 questions, which is pretty phenomenal. I mean, I have never done this many questions in my life with LeetCode. So let's go ahead and start. So I'm going to sort this by acceptance. We should by default be on page 1 here. Yep, page 1. So what we're going to do, we're going to start going down. We're going to start going down this list, and we're going to find the first one, like this one right here, largest local values in a matrix. We're always looking at ones that, maybe this one's new. I don't remember this one. This might be a new one. But really, the goal is to have all these filled out, right? So let's do this. It looks like so far, it's a decent question. It's a high-quality question, so I'm excited for it. You're given an n by n integer matrix grid, so we know it's a square off the bat. Generate an integer matrix max local of size n minus 2 times n minus 2. Such that max local I and j is equal to the largest value of the 3 by 3 matrix. Max local ij is equal to the largest value of the 3 by 3 matrix. Why is it a 3 by 3 matrix? Okay. In grid, centered around row I plus 1 and column j plus 1. Okay, I see. So it's always going to be... Right, we have these, we have this, 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 or we have this, this. Oh, 3 by 3. So 3 by 3, 3 by 3 here, 3 by 3 there, and 3 by 3 here. Then 3 by 3, or should it be 3 by 3 here? One square here, one square there, one square there, and then one square, one square, one square. I keep missing one. Yeah, there you go. These in the middle right here. Oh, interesting. The max local of each square. What if there's a function that I can write that I can traverse a square? Now the thing is, as I'm looking at this, right, there's definitely like a brute force way of doing it, which is looking at every single square, but some squares are going to have overlapping values, right? So it'd be nice if every single time I would keep track of previous ones, something like that. Because the maximum one here is 2, this is 2, and this is 2. Okay, what if we just found the maximum in each row and column? Let's say I'm going through this, I say the maximum is 1. I go through here, okay, this is 2. The 2 is contained within every contiguous. Yeah, I think this one's pretty tough. It's certainly not a very easy question, but let's see if we can figure out how to do this. Given maybe what I should do, is there a way that I can just sort of focus? By the way, if anyone, for people that are watching, there is one thing that I would like if you all could do for me, only because it's something new that I added to Streamlabs. Can you all try dropping a message on chat? I want to see if it shows up. I added a chat box, so I just want to see it. I just want to see if it shows up on the stream, because I think that's just a cool way of adding interactivity to the stream. So yeah, if you're watching, just mention anything, just say a comment, and I want to see if it shows up on the stream. Thanks for that, and I'll reply too. So the diagram above shows the original matrix and the generated matrix. Notice that each value in the generated matrix corresponds to the largest value of a contiguous 3 by 3 matrix. I mean, what if we kind of like zoomed in and for each one of these, we got the max? And that's how we sort of start 0, 1, 2, okay. Is it always gonna be, so 1 inward and we start getting all the squares up until length minus 1. Will that always be the case in the 3 by 3 matrix? Like even if I have, let me see, can I generate or like create grid online? I want to see something. Free online graph paper? Not graph paper. I want something that will allow for me to make like a grid so I can just picture this in my head. I mean, I guess. No, columns. Where are we doing the columns here? Oh, 1FR, 1FR, 1FR. I really gotta add. Is this not letting me? Okay, this is not helpful. CSS grid generator? Oh, here we go. So if I had something like this, if I just zoom one in, is it always just gonna be 111 until the previous one? So what I'm thinking about doing is like, what if I set my starting point to like row 1, 1? I go from 1 all the way to length minus 1 and all the way to the row length minus 1. And for each one, I have a function that will get, I can sort of like go around my current position, including myself. Or yeah, I think that's one thing that I can try. Let's try that out. It might not be the most effective way, but I think it's a start. So I'm at least excited for that. So first, I would like to, yeah, let's say, how do we want to start this? I want to start by traversing this. So I can say for let row, I want to start on row 1, row less than grid dot length minus 1, row plus plus, for let column equals 1, column less than grid dot length minus 1, also column plus plus. So I kind of just want to focus on these, right? This will be 1. This will go to column grid dot length. Grid dot length is out here, minus 1 is here, so it should just print these values in the middle. So let's do console.log grid of row column. Okay, I just want to run this and see. We should get 1, 1, 1, 1, 2, 1, 1, 1, 1. Oh, okay, this is 6, 2, 6. We have 6, 2, 2, 6. Okay, that's cool. Now I know that like for row 1, I can always push, like if I create, how do I want to create this 2D array here? We're going to create a result. I think the thing I would like to do now is figure out how to generate this. We can say row and column. I can always push. How often is it that I want to push to column, column? Do I just always say, oh, I know what I can do. We can sort of come up with our result up here. So we can say largest is equal to an empty array, right? Inside of here, we can say new row, const new row is this. Here we can say new row dot push grid of row column, right? And then out here, we do largest dot push new row. I'm setting the algorithm up. This is not the answer. So what is it that I'm doing, right? The first thing I did was I want to just figure out a loop so I can just get the values in the middle. Because with those values, I can create another function that will get the largest local, but we'll figure that out later. Now what I'm doing, step 2 is just like, okay, with those values, I want to generate some array like this. So I create a row with the inner columns, and then I append that row to my largest, and then I do the same again. So now if we console.log, it shouldn't be new row, right? That's going to be out of scope. It shouldn't be that. It should be this, largest. See what this gives us here. 6, 2, 2, 6. Okay. Now for each one, we can say get largest local. We're going to be given a row and a column. So how would it work for this? I think it should always be from the top left to the bottom right. Does that make sense? Like if I'm in row row your boat. Okay. If I'm in row column, this middle one, right? I want to start at row -1, column -1, right? And I want to go, yeah, this is going to be interesting. Let's see if we can figure this out. Like I want my columns to go to row of -1, column +1. Yeah, this is going to be very interesting. We're going to try and figure this out here. Let's create a new max. Const max is -infinity for let row equals, where are we going to start? We're going to start in the previous row. Let me think about this. Yeah, for let inner row equals row -1. Inner row is less than what? We only want to go up until, or we can actually make it equal. Let's see, so row is 1. We want to go up to row +1. And every single time we can do inner row plus. For the columns, what is it that we want to do? Right, because this will go here. For the columns, we can just always start at 0. Should we always start at 0? We shouldn't always start at 0. That's going to be the tricky part. How do I know to start? I guess it should always be, if I'm here, oh, I should always start 1 to the left of the column that I got. For let inner column equals column -1, right? Inner column less than or equal to column +1, inner col plus. Max equals to math.max of max, or grid of inner row, inner column. And at the end, we return the max. So what is it that we want to push now? We want to push, instead of new row.push grid row column, we want to push the largest local at row and column. Let me explain how this piece right here works, because I kind of just figured this one out on the fly. What I'm thinking about doing, so how do I set this whole thing up? I'm setting up a loop that traverses just like this inner square, because here, if I start here, right, I can generate all my different squares this way. And how do I figure out now how to get my largest local? I really want to start from, for example, I want to go from 9, and I want to just like loop through this square here. If I'm starting at 2, I want to start at 9 again, go through this piece right here. If I'm starting at 2, I want to start at 5. Go from 5 to 2, 8 to 6, 6 to 2. If I start at 6, I want to go 6 to 6, 2, 6, 4, 2, 2, 2. So I was thinking of like, if I'm given a row and a column, let's say in this case 1, 1, right? I want my inner row to start at row -1. So I want to start in this row. And I want my column to start at column -1, which is this column -1. So I start here. Inner row should go up until row +1. So it should consider this one. And similarly, column +1, like less than or equal to, it should consider this column, but not this column, right? And we'll just keep going that way. So I think I feel pretty good about this. Hopefully you all understand. If anyone's on the stream and they don't understand, I'd be really happy to explain it again. Let us go ahead. Let me move largest down here. By the way, really quick note, has really nothing to do with the algorithm, but you may have noticed, why is it that I moved largest down here? There's sort of this best principles practice of, I guess, localizing your creation of variables. And the reason is, a lot of people like to define all their variables at the top of their file, at the top of their function, but sometimes they might not use those variables until much later. So by declaring it close to where you use it, it just makes it easier. Like if I'm reading this code and I want to know, okay, what is largest in this case, I can just find it very easily. It's like right on top of the place that I'm using it. So here, let's return largest, and let's go for it. Okay, so less than or equal to, what happened here? Inner column less than or equal to column +1. Column -1, inner row less than or equal to row. Is there ever a time where I get out of bounds? Inner call is not defined. Oh, I spelled it wrong. Okay, cool. Let's run this. See what this does. Of course, I can't make that a constant. Let's run this again. 9, 9, and 8, 6. Okay, so it looks like we got the answer for the first one. Let's see the next one here. 2, 2, 2, 2, 2, 2, 2, 2, 2. Okay, let's run this. Cool, 23.27. Now, there's one thing that I'm thinking already that I feel like, and this might make it into like medium territory perhaps. There might be an easier way of doing this and I'm just not seeing it. But, and in reality, this kind of is maybe like a brute force way. But if I'm like already calculating this square, like when I go to 2, I'm kind of like recalculating new values, right? Like by the time I get to this square, I have to calculate like this column and this column, which the first one already calculated. It would be nice if like we only ever say like, if I have like, not like a, well, I guess we can have like a cache, right? Imagine I had a cache of like these 2 columns. And why is it that I'm saying this? Maybe let me draw this out. It's gonna take a while. Or actually, can I copy this into Excalidraw? Can I just like drop it in there? Oh my God, that's amazing. Okay, hear me out. This is what I'm thinking. What is it that I'm doing right now, right? If I'm starting, I don't want it to be transparent. If I'm starting at 6, right? I'm sort of like, I'm taking into account all these items here. Let me actually make this a little easier, right? All these items. That's like what happens if I start at 6. Then if I start at 2, I'm doing all these items. But check this out. If I start at 6, let me make this a different color. If I start at 6, like there is an overlap here, right? The overlap are like these 2 right here. So it would be nice if like I only calculate, like I guess the first time I calculate everything, and now I can somehow like keep a cache and just say, you know, maybe just like keep track of this column here. And when I calculate these 2, I don't even have to consider this one. I just say, compare the max of whatever these 2 plus this one. I don't know if that would really increase the efficiency, but that's one thing I'm thinking that maybe it might be like a moot point. Maybe it's just like it's a small optimization that's not as important as another one we maybe could be making. Maybe I can actually try and just get like the maximum of each one in here. Like if I got the maximum of every row and the maximum of every column, wouldn't that give us the answer? Let's see if we can get that. Like what's the max of this row? It's 9. All right, so I'm gonna do this. I'm gonna say, okay, this is 9. Let me make this larger. What's the maximum of this row? 5, 6, 2, 6. So we can say this is 6. Here it's 8. Here it's 6. Over here, this column is what? 9. 9. We have 8 and we have 6. So like, can we just get like, okay, at this row and column is 9. This row and column is 9. We just get the max for both. We get the max for both. So could I actually just, you see, but here then it messes up, right? Because here now we no longer have access to, I need to know for all the rows and columns. I almost think maybe something like this could help. I'm not entirely convinced right now. Let me run this again because there's always a huge differential in time complexity here. 75, so it became a little bit better. Maybe I'll run it one more time. Okay, so let's think about this. Let's try and figure out what like the time complexity is. So like this one right here, we're only going through like in an n by n matrix. Let me pull this up again. In an n by n matrix, right? This is 16 and we're only going through 4. I'm only traversing through 4 here, right? And then I keep clicking all around. If I'm doing this one, this is what, 25, and I'm going through what, 9. So if we have a 25 to 9, and we also have a 16 to 4. So like, what's the relationship here? It's only like the inner cell. How can are we decreasing it by a factor of 2, I guess, or so, something like that? It's not, you get me, it's not like how do I get the size of the inner square given the outer square? Is it just like n squared minus something? Or n squared minus n? N squared 4 minus n, no. N squared 4 to 4 is 16. 16 to 4, I mean, that's like 12. But what is that relationship? I'm trying to figure out, like, how do we get, this is by 2, this is by 4. Oh, wait, is it the square? No, it definitely can't be the square root. What am I talking about? Because we went from 25 cells to only processing 9 in this one. 3, 6, 9. And this is 5 by 5. There's 25, but we only processed 9 cells in this piece. If anyone knows like what that calculation would be, let's see, formula for size of inner square within grid. I don't know. No. Number of square. How to find total number of squares within a square. A square of n by n. Number of squares in the grid. Is this like some crazy 4 by 4, 1 times 2 times 3? Hope you got it. Of any size and a square of size m by n. Oh, this is squares. Anyway, I'm almost thinking that like it'd be nice if I can get that time complexity, and then this here will always be constant, right? I mean, this is always just going to be 3 by 3. So this is almost like this is a constant time operation. It's just figuring out what the time complexity of this is. That I'm not entirely sure of, but it might be something very specific. Let me run this one more time, and then I'm going to go ahead and we'll look at discussions, see what it has to say, because it does look like there's probably a faster way of doing this. Let's see what we can do. For loops. It's easy to overthink this problem. For each output cell, we need to process 9 input cells. Okay, so what do they do here? They go for int I, n minus 2. Okay, n minus 2, and then we do I plus 3. Oh yeah, it's exactly what I did. So I'm happy with this. I'm happy that, like, despite this person not always having amazing answers, I'm happy that at least our answer correlated with whatever he put here. So I think that's pretty neat. By the way, I'll say it again because it's been a while already. I see there's like a couple of people watching. If you are watching, can you just leave a comment in the chat or leave a message, because I'm very curious to see if the chat box widget that I created is actually working. And I hope it's like outputting all the chat. I'm not sure like if it's just YouTube or hopefully it's also Twitch, but I guess we'll figure it out. Okay, so I'm happy with this one. This is a good problem to start off our weekly roundup. I'm gonna add this one to my list, and I'll make sure to also upload it to the site once we're done. All right, so let's go back to problems. Let's get to the next one here. Let's see. Okay, nice. So that's gonna leave us at doing every single question on page 1. So that currently we're all up on page 1, so that's good. Let's get to our next one. Oh, this one is still crazy. Remove palindromic subsequences. Maybe we can spend a little bit of time on this, but this one for me has been historically difficult. This one's tough for me. And since I've been spending a lot of time on it in previous weekly roundups, I'm going to again skip it. We can get to it maybe at the end. Maybe at the end when we have like 10 questions left, I'll do like a really, really long stream where we just finish the remainder of the questions. Like we have 590 questions in easy and we've done 183. So I could see a point where we're like at 580 and we have like 10 questions left, and I just do like a 3 or 4 hour stream of us just doing all 10 questions and just boom, finishing it all. All right, let's see this one. Final prices with a special discount in shop. So given the array prices, where prices of I is the price of the ith item in a shop. So let's see, given the array prices I, so this is price of the ith item in a shop. Okay. There's a special discount for items in the shop. If you buy the ith item, then you will receive a discount equivalent to prices j, where j is the minimum index such that it's greater than I and prices j is less than. Okay, So you want to find the first time that we get to something that's smaller. So here, right, we'll get 2, 6 will be 2, and then 2 will stay the same. So could we do this with the monotonic stack? Like we always want to find the thing that is less. So a monotonic stack is like a data structure that allows for us to keep order of elements in some array. We can either always have it going in increasing order or always having it in decreasing order. So here we would want to create an increasing monotonic stack, so that way when we find something that's less, we can assign it to the one that we just popped off. What do I mean by that? Let's say we have 8, 4, 6, 2, 3, right? We push 8. Okay, that's cool. We want the next one to be bigger, right? So because 4 is not bigger, we pop 8 off. And now we know that for 8, 4 is the next lowest thing. So here we can say 4 for 8. And I'm going to leave these blank for now because we're going to come back to these. All right, we're going to come back to those. So that's 4 for the first one. Now we have a 4. Okay. Now we have 6. That's bigger, so that's cool. Now we have a 2. 2 is less than 6, so wherever 6 is, we can put a 4. Okay, we pop 6 off. 2 is less than 4, so wherever 4 is, we put a 2. Okay. We leave the 2 there. Now we get to the next one, that's 3. Okay, and now we can just push this, because none of these, the things that are left, don't have any, like, how do I say this? They don't have any, like, they can't be applied to any item. I don't know why that was so hard for me to say. Now, are these, okay, so these are not unique. So we need to figure out a way to, like, if I get to this, 10, 1, 1, 6, let's say, okay, I push 10, 1 is not greater, so I pop the 10 off, and I assign 9 to this. Now I'm at 1. I get to 1, 1 is not greater, so I push the 1 off. But like, which one do I push off, right? It needs to be, it needs to be the last one that I've seen. I don't think I can see a new one until I've processed it. Like, I only add it after I've processed it. I think that's what we can do. Something like so only add the index after processing. Something like this is what I'm thinking. So let's see if we can translate this to code. Monotonic stacks are, there's like a template for them. Let me make sure that we're all sounding good here. Okay, cool. Monotonic stacks, there's a template that we can follow. So let's say we're going to create a new stack. And let's also create an index map. So let's say const index map, and we'll set this equal to an empty object literal to begin with. So we can say for let I equals 0, I less than prices.length, I plus plus. What is it that we want to do? So like I always want to push something to stack, but only if this current number is less than the previous one do I want to do something. So normally that looks something like, while stack.length is greater than 0 and prices of I is less, right? Prices of I is less than stack at stack.length minus 1. Here is where we do something. Else, we can just go ahead and push it onto our stack. Prices of I. We should do push prices of I, and we should also say index map of prices of I equals I. So just based on this, I want to go through an example again. Let's actually use this one because we have duplicates. This is our input. This is our index map, which I'll leave empty for now, and this is our stack. Okay, so we're going to put I here. This is something I do for every single one of my questions. We're going to manually debug this and work through it. So 10, we start at 10 here. So for let I equals 0, while stack.length is greater than 0, which is not, so we can immediately go to the next thing. So inside of here, we'll say 10 belongs to 0. And in my stack, I'll push 10. I go to the next thing. While stack.length is greater than 0, it is. And while prices of I, 1, is less than 10, what is it that we want to do? So for this one, let's see, we should do, we're gonna pop off, yeah, we should pop the current thing at the stack. So we can say const previous price is equal to stack dot pop, right? And now I think for our output, do I actually need to find, do I even need to care? I might not even need index map. Because just for this first one right here, I think we can just immediately push. So let's get our result here. Say const discounts, right? Here we can say discounts dot push the previous price minus, let's see, whatever prices of I is, right? Prices of I. So prices of I is 1. We pop this one off. So now in our result stack, so like, right, we have this here. We pop this off. Our result stack now has 9. Stack is no longer greater than 0. So now we can push the thing that we just got, right? Let's also create this index map. Let's kind of keep it going. Like 1 is 1. Now we push 1. We get to the next thing. For let I equals 0, we increase, right? We're going to increase again. While prices of I is less than or equal to, so that's something I just discovered here. Previous price, stack.pop, that's 1. Discounts is previous price minus prices of I. So that's going to be 0. That's what we'll push here. We'll again pop this one. We exit that loop. Now we push this one, and maybe here we say this is 2. But now, as I'm looking through this, we might not need this. We get to 6. Stack.length is greater than 0. I think, yeah, oh yeah, we should push the 0 here. No, actually, no, yeah, that was already that one. Now we say stack.length is greater than 0. It is, but this is not less. So we push onto our stack 1 and 6. Don't think we need this index map. I don't think we need this index map here. Now we're just left with 1 and 6, and we can push 1 and 6 to the end. So discounts, we have our stack. We can say for let I equals 0, I less than stack.length, I plus plus. We can say discounts.push stack at I. Return discounts. I feel like that could be the answer there. Just a classic monotonic stack problem. Let's run this and let's see what we get. Do we need to remember 4 to 4? So why did this happen? Let's look into this and see. Oh, kind of messed up something here. Okay. Why did that happen? Let's go through this again. We have our stack. Okay, so while stack, nope, we can just stack.push prices of I, we push 8. While stack.length is greater than 0 and prices of I is less than or equal to stack at stack.length minus 1, it is. Previous price is 8. We push 8 minus 4, that's 4. And now we push 4 onto our stack. Stack.length is greater than 0 and prices of I, oh, wait a second. Do I want to keep doing discounts.push? Oh, okay, and then we push 4. Okay. We did 8. Okay, cool. We get here. Now we get to the 6. While stack.length is greater than 0 and 6 is less than or equal to 4, it's not, so we just immediately push 6. You see, that's why, like, the 2, this is why we need the map. Because the 2 corresponds to the 6, but we're immediately pushing the 4 here. So I do think that we need the map. I do think we need that index map. So if I come back to here, let's say, actually, let me just undo a lot of stuff so we can get back to where we were. Index map, okay. Let me also copy this since that's good. Whoa. I like zoomed out too much there. Okay, I know I'm like kind of going all over the place here, but yeah, that's what I want right there. Let's do this. Let me remove move this, make this a little bigger for everyone. I think what we can do here is now our discounts should be a new array that's of the size of prices.length. Now, instead of doing discounts.push previous price minus prices of I, we need to push it wherever the previous price was. Yeah, we need to find the current location. So we're going to say here, discounts at what location? At index map of previous price equals previous price minus prices of I. I'm just going to run that and see what that does, just off the cuff. Let's just go for it. 424, we have this weird thing going on here. That's fine. Let's see. Oh, discounts.push. Yeah, so this, let's see. Am I always going to push index prices? I probably should do the same thing here, right? Discounts at index map, not of previous price. This shouldn't be previous price now. This should now be stack of I equals stack of I. Hopefully this should retain its original index. 42423. Okay. Let's run this again. See what we got. 1, 2, 3, 4, 5, 9016, 9016. Okay. So sort of a modified monotonic stack where we also keep track of previous indices, because we can get to a case where if the lowest item is not the next one, like for example 6, we can't just immediately push 6 minus 2, because 6 minus 2 should go in index 2, and 4 minus 2 should go into index 1. So we need this index map to help us keep track of those indices. Let me submit this and see what we get. Nice. Very, very good problem. Like, you should definitely understand how to do this. Phenomenal problem. We'll definitely be adding that to my list. And let's see if we can think about a time complexity here. So in the worst case, like I'm seeing this as like this is going to be length of prices. While stack.length is greater than 0, this could at the worst case run like the lowest thing could be like, what if it was like 8, 10, 12, 14, and then 2? Would essentially have to like loop all the way back, right, to the beginning. So I see that as like an n squared solution, because this could be n and this could potentially be n squared. Now, is it always going to happen? Yeah, I think overall this will be n squared, and this will just happen some n times. So I think the time complexity here will be n squared. Magic boy, hello. You see, like it doesn't show the chat box. Is there something I'm not doing right? Give me a second. Now am I moving the? Did that show on the stream that I moved it? Oh, that's funny. Let me try something since you mentioned something here, Magic boy. Hello. You see, so that chat box right there, that chat box isn't working. I'm going to spend like a minute. Let's see if we can do this live. You're going to help me test something out, Magic boy. Hello, Segoy. Hello. Background color, clean, widget editor, chat delay, sources and settings, source, shutdown, refresh browser, body, background. Is this because it's like text color, font size, theme, background color, disable message animations? Let's see. Give me 1 second. I really want to try and figure this out. Streamlabs, chatter. Is it Chatterbox? Chatbox. Chatbox not showing. No, that's just like, that's an example. That's an example of like what it should look like. Let me see. Chatbox. If you guys can give me like 1 minute, I really want to try and figure this out. I'm just going to put the be right back sign up real quick. Do I have to condense this? Has this not been like the right resolution this whole time? Oh, I'm modifying the screen size live. Oh, wait, there you go. I see it. Did you guys see that? I saw Segoy's message there. Yes, yes, it's fine. Oh, look at that. Look at that. Let's make this a little bit larger. Let's do like 24. Text color, I guess it should be white, right? Can we try again? Does it work if I do it? Hello world. Oh man, that is so cool. That's awesome. I really wanted to, like, I don't know what I just did to get that to work, but hey, it works now. Is it gonna look weird here? Nah, it should be fine. We're gonna tinker with it as we go along, but we're learning. I'm learning actually how to do all this stuff. So, you know, if there's like some places it'll look better than others, but I'm really happy about that. That's very cool. Thank you all for experiencing that with me. Okay, sweet. So we've done 2 questions so far, 2 questions that I think have been very cool. Let me remove some stuff here and let's see if we can do another one. Counting bits. Ooh, I liked this question, but I didn't add it to my list though. But yeah, this one used to be a long time ago when I started to do LeetCode. This used to be like the first medium question that you could do. So I don't think this is like they're saying that it's very easy to come up with an n log n, but in linear time, in a single pass, I think that can make it very difficult because I'm not entirely sure how we can do that. There's a pattern to how many bits appear in any number from 1 through n. I think that's the piece here that we're missing. And I've tried to like, let me see, Scaladraw. Yeah. I've tried to draw up examples of it, but I can't figure it out. Like if we do, let's say we're going to do like 0, 0, 0, 0, 0, 1, 0, 0, let's do 2, 3, 4, 5, 6, 7, and 8, right? Something like this. So like, and we could even do more to try. We probably should do more, at least one more. This always becomes confusing though. If I want to do 9, I'll do this. 10, 11, 12, 13, 14, 15, and then 1, 2, 3, 4. That's 16 there. So what I'm trying to do is trying to figure out, like, for each one of these numbers, where does the pattern occur, right? So we have 0 set bits. It's like 0, 1, 1, 2, 1, 2, 2, 3, 1, 2, 2, 3, 2, 3, 3, 4. But then we're back at a 1 here. That's the part that makes it, like, difficult. Can we use any sort of, like, bit shifting here in one pass in linear time and possibly in a single pass? Because it's easy to, like they're saying, it's easy to come up with, like, we could do, we might as well, let's figure this out for, like, we can do const result. I'm going to figure out the easy way for let I equals 0, I less than or equal to n, I plus plus. We'll say let Hamming weight equals 0 while n not equal to 0. We can just say while n Hamming weight plus plus n equals n and n minus 1. And we can say result dot push Hamming weight. Return results. So I think this is the answer they're talking about, n log n. Or not. Oh, while I. This should be while I. Where did I get n from? Yeah. This should be while I. Oh, is that gonna... Yeah. Ooh. Wait. Let current digit equals I. Let's definitely not modify I, right? Because then we're modifying the thing that we're using to increase in our loop. 0, 1, 1, we'll go through all our test cases. 0, 1, 1, 2, 1, 2. If we submit this, so this is n log n, right? 57.71, because this operation right here is a log n operation, and we're going through n digits, so it's n log n. Now, how to do it in a linear time in a single pass? There's got to be there's definitely a mapping of digits here that we need to be looking at. Let's see, binary representation of numbers from 1 to 100. Is there a list that I can look at? That's not very helpful though. Binary numbers list. I'm gonna try something fun. We're about to do something crazy. Maybe. Let's see. Because I want to get a list of all these numbers, and while I'm here, I just want to have a little bit of fun with JavaScript. So TR TD11, but we want the second TD. TD T-body TH T1. Let's see, this is gonna be really fun. Const, what is it? T-body equals this thing. T-body is that. What if it T-body for each row? We can get for each row. What is it that I want? What is it that I want to do? Can I get const last equals row? Is there like a last child? T-body. Oh, that's not even okay. T-body dot child nodes for each. Oh, but do I only want like the immediate child nodes for each. Does it need to be children? 101, okay. For each console.log. T-body children for each is not a function. What I really want to do is I just want to like concatenate all these values here. That would be very fun. Okay, I think what we can do is we can say row array equals array dot from t-body dot children. Okay. Now inside of here, we can say const values equals row array dot map. We have a row. I can say row dot, is there like a last child in MDN? Like last of type node dot last child returns the last child of the node. Will that actually work? If I map and just return the last child property of the node interface, value or null. It's an abstract class. Can I actually get the, okay, I can get the text content. Oh man, that worked. Yeah, what if now I just do values equals values dot slice from 1. Oh really? Okay. Let's just do const sliced equals values dot slice from 1. Nice. So now, can we actually, let's open up VS Code. Oh wait, we need to copy this. Copy sliced. Can I just like paste this whole, oh look at that, look at that. Okay, nice. So we have all the binary digits now. Nice little exercise in JavaScript. automated the heck out of that. Okay, so what is the pattern here? I'm gonna make a column over here and say, okay, we have like 1, or maybe I can come up with that a little bit better. We have 1, 1, 1, 2, 1. Oh wait, but this is 1, 2, 1, 1, 2, 1, 2, 2, 3, 1, 2, 2, 3, 2, 2, 3, 4, 1, 2, 2, 3, 2, 3, 3, 4, 2, 3, 3, 4, 3, 4. You see, it's like where and when does it become different here? It's going to be some pattern that we get from this, right? Definitely going to have to... Why is it that like... Okay, by the way, CS Practice Live, very happy that you followed me. I really wish that the alert box would come up on... Is there like subscription, YouTube subscribers? How do we do... Oh, is that only... Ah, okay. Subscription? Is it Twitch follow the same as a... Oh, that's so dumb. That's why. Subscription is not the same. I'm gonna make one right now for CS Practice Live. Let me see. CS Practice Live is now following. Let's see how it comes out. Nope, that's not what I wanted it to say. Oh, I guess that's just doing a test. Well, it's okay. We got the chat box working. Now we just need someone else to follow me on Twitch, so that way we can see it on the stream here. Yeah, now it should... Okay, nice. Okay, so if we come up with some pattern for this, that's going to be what helps us. So I guess I can start doing that. Like 1, 1, 2, 1, 2, 2, 3, 1, 2, 2, 3, 2, 3, 3, 4, 1, 2, 2, 3, 2, 3, 3, 4, 2, 2. No, that's 3, 3, 4, 3, 3, 4, 5. So can we see a pattern here? 1, 1, 2, 1, 2, 2, 3, 1, 2, 2, 3, 2, 3, 3, 4, 1. Then it goes like back to 1 for whatever reason. But then it goes to 1, 2, 2, 3, 2, 3, 3, 4, 1, 2, 2, 3, 1, 2, 2, 3, 2, 3, 3, 4. So that does come back up. 1, 1, 2, 1, 2, 1, 1, 2, 1, 2, 2, 3, 1, 2. That's weird. 1, 1, 2, 1, 2, 2, 3, 1. Yeah, I think the secret to solving this question is coming up with some pattern like this. And it's really hard for me to see that pattern unless I draw. Like, we'll have to spend more time on that. Maybe this is one of those ones that we'll solve in the end when we have like the 10-hour stream or whatever. I keep extending the time of that stream. It's pretty funny. I'm gonna have to. I'll leave it like this for now. I'm okay with this answer, but could we do better? We definitely can. Should we look at discussions? I don't think so just yet, but I guess I'm fine with that. 90.66. I'll take it. Let's come up to the next one. Merge similar items. You're given a 2D integer, given a 2D integer array, items 1 and items 2, representing two sets of items. Each array items has the following properties. Items I is value I weight, where value I represents the value and weight. Okay. Value of each item in items is unique. Return a 2D integer array, where ret is value weight, with weight being the sum of weights of all items with value I. Okay, items 2. The item with value 1 occurs in items 1 with weight 1 and items 2 with weight 5. Total weight is 1 plus 5. Okay, 139. So we just need to keep the track of value and weight. We need a map of values to weights. So we need something like a weight map. Okay. I think what we can do here, we can say like calculate calculate weights. And we can actually just do this once. We can say, yeah, we can go like for const, let's see, value and weight of items 1, weight map of value equals weight map of value plus weight or weight, right? So we can say here, let's just make a function for this, like calculate weights. That could just be like a normal function. We'll just do this, stick that guy in there. And of items 1, we'll just pass in whatever items in here. So this can be of items, weight value, weight map. Okay, so now here we can call this twice. Calculate weights for items 1. Calculate weights for items 2. So the value with item 1 occurs in items 1. Okay, 163945. And they want us to return this. The ret should be returned in ascending order by value. I mean, could we just sort? Could we just like get, I think what we can do, how many, 1,000, value, each one is unique. Items 1.length, items I, the value is less than 1,000. I mean, we could declare an array of size 1,000, but I also feel like maybe I could just do, I mean, I can do object.entries, return object.entries of weight map. We can sort, I mean, we'll get weight 1. We can do weight 1, weight 2. We can do weight of 1 of 0 minus weight 2 of 0. Will this not work? 163945. Bottleneck here is going to be the sort. It's n log n. 142434, 172471. The uniqueness part, I think, is definitely the important piece. It says each value is unique. Was that what it said? The weight, the value of each value and items is unique. I think what we can do is, why don't we just create items 1.length less than 1,000. The value is less than 1,000. So what if we just do, instead of weight map, I mean, it might make it a little bit faster and we wouldn't need to sort. I think what we can do is we can say const weights. So this is we're going to do something that we've done a lot. We're going to use the fact that this is a small enough space that we can create an array, and because each value is sorted, we'll just put the value in its respective index, and then we can just loop through the array once at the end. So what is this right now? Like time complexity, right? Right now, items 1 and items 2, they're both different lengths. So this will be like, let's say O of items 1 plus items 2. Right? And this will just be n log n, like weight map will just be all the unique numbers. So this is essentially n log n. So O of items 1 plus items 2 plus O of n log n. That's what that solution is. Now, if I comment this out, let me copy this and comment it out, or we can just do it again. Let's say weights now is a new array of size 1001. I can still keep this method here, which I'll comment again. But now what I'll do is in items for const value of weight, and let's make sure I fill this up with 0. Do I need for this to be? Yeah, it'd be nice if this should actually be Yeah, I'll fill all this up with 0 to begin with. And then what we'll do is at that position, what is it that I want to do? I can create a new object at that position that has like a count. Right? It'd be nice if we can do that. Is there another way that we can? Let me think about this. Maybe some of them will be 0. Maybe all of them should have. Maybe, what if I just filled it all up with like an empty object? Or, no, wait a second. We don't even need, we can just make all that 0, right? For const weight value, we can just say weight map, like weights. Yeah, we can just say weights at value plus or equal weight. Right, we can just say that. Weights of value plus or equals weight. Right, and then our result, say merged, we'll go for let I equals 0, I less than weights dot length, I plus plus. If weights of I is greater than 0, then we say merged dot push a new array where we have the value and weights of I. And here we return merged. Let's try this out. Okay, let's see. Where is it that we went wrong here? Oh, of course, we didn't even call calculate weights. We still need to call this twice, right? Okay, so let's run this. 163945, 142434, 172471. Okay, looks good. Let's see, 65.15. Will this run faster? 60. Well, the first one ran at 65. The previous one was like lower. So let's try this one more time. 27.27. 70%. Is there anything else that we can do to make it go even faster? Items 1 and items 2. I don't know if on 1, 4, 5. Do I even need to do, these are all unique. I don't even need to set, I don't even need to do plus or equals weight. And you know what? Maybe we don't even need, yeah, these are all unique. So there's potentially a lot that I'm not even using here. 93.64. Well, because now, so before it was O of items 1 plus items 2 plus O of n log n. So previously we were, I guess we're still using the same amount of space, but we've reduced our time complexity because now, I mean, we're not even, this is actually constant, right? This is always going through loop through an array of size 1001. It doesn't matter the size of items 1 or items 2. So we've gone from like of O of n plus n plus n log n to just O of n plus n. So I'm pretty happy with that. Nice 2 different solutions for a problem. I know some of these differ drastically, but I feel pretty good about both these solutions. We can say what discussions have to say. Probably, let me see, where's our guy over here? One-liner. That's not very easy to look at. Okay. Tree map. Weight is value, and then just go through each one. 1005. I don't know why it's 1005. That's interesting. But it seems like it's pretty much the same thing we did. So I really enjoyed the questions we did today. We did a lot of high quality questions, so I'm very happy about that. Just a couple of things before we wrap up. So I have to update the video from yesterday to put the chapters and the questions. I'm going to do the same thing for today's video, and then I'll go ahead and update the website just in case if anyone's around and you don't know what website I'm talking about. It's this website right here. So rafaelslist.com is my website where I keep track of all the top quality questions we do, and people that view the website can keep track of their own progress by checking off the boxes here, and they can also look at all the different streams that each one of these questions was presented in. So I think that's pretty neat. Might also fix some things here with this like weird spacing here, but I guess that's like for another bug, right? I'm probably gonna fill out a bug in my repo. So for everyone that joined, thank you all so much for watching. It was nice to see some familiar faces. We'll be continuing tomorrow with our normal LeetCode live stream, so hope to see you all then. Hope you guys have a great rest of your Saturday. I know I will. I'm actually going to go and play some Fallout 3, so I'm going to be doing that now. And we'll see you all again tomorrow for another stream. So happy coding.